In this video, we'll solve nonlinear systems of inequalities. To solve a system of inequalities, we graph the solution set for each inequality in the system of coordinates and then shade the intersection of these solutions. So we're looking for the common part of these solutions. Let's see the steps how to solve system of inequalities by looking at this example. The first thing that we need to do is to graph the boundary curves. That means replace the inequality by an equation and graph the shape. By now, we know already that x squared plus y squared equals 4 represents a circle with center at the origin and radius 2. We also need to watch if the inequality involves equation or not. If it does include equation, we're supposed to use a solid line to graph the boundary curve, in this case a circle. And in the second inequality, we have strong inequality, no equation, so the shape that this related equation describes should be graphed by a broken line, dashed line. So let's graph the first boundary curve by a solid line, as the equation is included in our inequality. That's a circle with center 0, 0 and radius 2. So we have 2 here, 2 there, -2 and -2. As you see, this circle divides the whole plane into two regions, the inside of the circle and the outside of the circle. So we need to make a decision which part of the plane should be shaded, which part of the plane represents solutions to this first inequality. Therefore, the second step is to make this decision. To do that, we can use our intuition, looking at the inequality and thinking geometrically, what does this mean? Well, my x squared plus y squared describes a circle, so the points that will satisfy this inequality will have to lie not farther than 2 steps from 0. This is because the radius of the circle is 2, and we're talking about the inner part of the circle if the inequality is smaller equal. For the bigger equal, it will be outer part of the circle, but for the smaller equal, it's inner. That's the geometry of it, but if you are not sure, you can always test a point to decide which part of the plane will contain solutions to this inequality. Such test point must lie not on the boundary curve, because such point would not help us to make any decision about the regions. It would just inform us that points on the curve satisfy the inequality, and we know that because the equation is already there. So what we need to do is choose a test point that is not on the boundary curve. However, choose an easy point to calculate. The best idea is to choose a point 0, 0. That's the easiest to calculate. The only way that this point won't work is if this point is actually on the boundary curve. Then you can switch it into 0, 1 or 1, 0, something that is not on the curve. Now, after we have the point, in our case the point is here, then we need to test it. Test means plug in the coordinates of this point, in this case 0, 0, and see if it satisfies the inequality. So if I plug in 0 for x and y, I end up with 0 smaller equal 4. Now my question is it true or not? Well, is 0 smaller equal than 4? Yes, it is. So that tells me that the region that contains this point is actually the region of all solutions to the first inequality. Okay, so I can shade it to indicate that this is my solution set. Everything what's in a circle together with the boundary. And it's a good idea to record the color that we used for each of the inequalities. So let's look at the second inequality. This time we have a strong inequality. We don't have equation, so we should use broken line. And what kind of curve is that? Well, when we rewrite this using equation and bring the x to the other side, we have y equals x plus 1. That's our boundary curve. And what we see here, well, it's a line that comes through the point 1 and has a slope 1 as well. Let's graph it. So that's our line, comes through the point 1 on the y-axis It has 1 as an x-intercept, and the slope of it is 1 as well. So now, similarly as before, we need to make decision which half a plane should we shade. So the inequality is actually y larger than x plus 1. Again, we can use our intuition. Y larger than x plus 1 means y values must be above the line. So all the y values that are above this line. But if we are not quite sure, or if we just want to confirm that that's the region, let's choose a testing point. Again, if I choose 0, 0 point, first check 0, 0 is not on the line. So when I plug into the inequality, I end up with 0 bigger than 0 plus 1, which is 1. Is that true or false? Obviously, this time it's false. So that means that the region that contains this point, this half a plane, does not contain solutions. Therefore, the solution set to this inequality is the other half a plane, is this half a plane, but without the border. So the border is a broken line here. Okay, let's record blue as a color for the solution set of the second inequality. Since we are looking for the solutions to both inequalities, we're really looking for points that belong to the yellow region as well as to the blue region, which means we're looking for the intersection of these two regions. Okay, the intersection is yellow and blue. That means this part inside the circle. Everything, let's mark it in green. That will be the final answer for this system of inequalities. We also need to watch the boundary points. So, since points on the circle and in the blue region satisfy both inequalities, they should be included in the solution set. However, the points on the line, since they do not satisfy the second inequality, they have to be excluded from the solution set. We should also make a decision about the corners, those two intercepts. Since this corner point does not belong to the line, it does not satisfy the second inequality. Therefore, it should be excluded from the overall solution set. We should mark an open circle around this point. Similarly, the second intersection, it should be marked by an open circle. So the final solution consists of this section of the circle with the boundary on the circle, but without the line that works like a chord of the circle, and without the endpoints. And to make sure that our graph clearly shows the final solution set, it's a good idea to give the answer. The solution set for this system of inequalities is marked in green. Or, to show clearly what you had in mind, please do the preliminary shadings in yellow and blue very lightly, and the final shading do it stronger. Here, since I have an eraser, I could erase the yellow part and the blue part and just leave the final answer, so it will be clearly visible. So this means that if I choose a point within the green region, then the coordinates of such point will satisfy both inequalities. And if I choose some other point that is not in the green region, those coordinates will not satisfy at least one of those inequalities. Let's try another example. Again, if I look at the first inequality, this has something to do with an ellipse. However, we don't have equal sign, so we need to draw this ellipse using dashed line. What do we know about this shape? Well, the radius along the x-axis, rx, is equal to square root of this number, so it's 3, and the radius along the y-axis is equal to 2. So the box is like 3 is here and 2 is over there, -3, -2. So that's our box that should contain the full ellipse. Let's graph it. Okay, our ellipse looks like this. And now again we need to make a decision which part of the plane should be shaded, the inside of the ellipse or the outside of it. If I choose a testing point 0, 0, plug in 0, 0 for x and y, I will end up with 0 bigger than 1. Is that true or false? Obviously it's false. That means that our shading should be outside of the ellipse. Okay, let's shade it. Looks like a sun. Kind of distorted sun. So the solution to the first inequality was marked in green. And I will choose orange for the second curve. What is the second curve? Oh, that's something about parabola. It's upside down parabola. And since we have equal sign, we should use solid line. Okay, let's graph it. The parabola looks like this. The vertex is at 0, 0, goes 1 across, 1 down, and 1 to the left, 1 down. Again, we need to make a decision which part of the plane should be shaded. The one that is below the parabola or the one that is above the parabola. Since y is smaller equal than the formula for the parabola, so the y values are below. That's my intuition. But let's say if I'm not quite sure about it, let's choose a testing point. Which point should we use? Well, this time 0, 0 won't work because it's on the curve. So let's choose something else. For example, 0, negative 1. So if I test 0, negative 1, 0 is for x, negative 1 is for y. I end up with negative 1 smaller equal 0. True or false? Yes, it's true. Negative 1 is indeed smaller equal 0. So, since this is true, all the solutions to this inequality are in the region that contains the testing point. So they are here. Okay, I can highlight it a little bit stronger. Solution set is below the parabola and everything on the parabola should be taken as well. So all this stuff. Okay, now to produce the final answer. So orange represents the solution set to the second inequality. Finally, let's give the overall solution in red. Answer. The solution set is marked in red. That will be the intersection of these two solution sets. So intersection of green and orange. Now the common part of green and orange is actually here. Everything was here. But the part of the ellipse will be dashed. And since the corners, the intersection of the parabola and an ellipse, do not belong to the ellipse, and since the corners, the intersection of the parabola and ellipse, do not belong to the ellipse, we need to put an open circle. So the red shape is solid line here, dashed line over there, solid line over there. The corners are excluded and everything what's inside. Let's mark it more clearly what's inside, everything what's here. That's our solution set. So as you see, solving systems of inequalities, it's not really difficult. It's actually very artistic. You can create many colorful pictures. You just need to be very careful when you attend the details, especially the border lines and the intersection points. Should you include it or exclude it? You would include the intersection point only if it is intersection of two solid lines. If at least one of those lines is broken, the point should be excluded.